Hi guys, today I've decided to show off the hamster tracker that I've created. I'll show how to create the very basic setup for the particle board, and we'll see how far that gets us in an hour. Hopefully I can show off the Keen IO stuff too. It's the morning time, so the hamster is sleeping. This is Jessica Rabbit Hamster inside her igloo. And here is the sensor I set up. I attached two magnets to the wheel here. And I've set up a particle photon with the magnet sensor and a thermometer, a temperature sensor, using the Grove starter kit that I got at an Intel Edison hackathon. Okay. So the goal here is to put the magnet sensor near the wheel so that when the wheel spins, it will keep track of how many rotations it does. After a certain amount of time, if it has stopped moving, it'll send that information up to Keen.io, and they're kind of a big data sort of group, and then you can use that to query and get neat charts. I can show you how it looks now. So here's how it's looking. Let's refresh it to make it look better. Here's how it's looking now. This is how much she's run. This is the average speed. Here's an area graph of when she runs. This is the current speed and the current distance. We can test this right now. I've got the sensor right here. I've got an extra magnet. So we just go like this, and that will set off the sensor to set off the speed. Just like that. Alright, to set this up, what we want to do we can start with the temperature sensor. We're gonna use the HTTP client as well, so we'll just add that in now. This will send our information up. So I've made a new app called Hamster Tracker, like so. And get math.h in there just cuz. Alright, so we're going to save the temperature. Now, the thermistor has a B value, which you have to look up. The one that came in mine is a version 1.1, so it will have a B value of 4250, I believe. Let's see. Now, we'll get a reading from the thermistor, then we'll get a resistance. We'll calculate a resistance from that, and we'll calculate the temperature from that. And we'll just set that to -1 right now. Alright, we want to tell it which one we've connected this to, and we've connected the temperature sensor to port A0 right there. So that's how that's set up. So that's how you start with the temperature. Now you set it up. All right, just set it up. Oh, there's one more thing. There might be a better way to use this, or there is a way you can use the onboard elapsed time, but I found it's easier to use the elapsed millis. Add that there. That just deleted everything I did, didn't it? It's kind of annoying. Let's get back in. Include math.h to do math stuff. Get temporary variable. This the b value thermistor with analog value 1. Okay, and we'll save, because let's not make that happen again. Now what we want to do is only measure the temperature sensor every once in a while. So we'll do this. We'll save that for later. We will use temp update, like that. Okay, so what we're gonna do is we're gonna pin mode sensor, set that to input, set the elapsed millis to that, and we'll make a new function to update the temperature, just to start it off. And in the loop, we're going to use if it's been over 10 seconds, then we update the temperature. And reset the timer for the temp update. Okay. Now, to do the new update the temperature, to get a new temperature, here's what we do. Like so. We set the analog value, then we set the resistance. Now this function is something I found on the internet, so I can give you the source, but I'm not too sure about it myself. I've spent a lot of time trying to figure out what it actually means. but I don't quite get it yet. If you want to explain it to me, I would really appreciate it. Now, our temp C is a variable, like so. Now, there's a couple ways that that particle will let you put the data up. There's the pull method and the push method. The fun way is to publish it. So let's go particle.publish temperature, like so. Okay? Now, that means that when you publish, oops, I spelled it wrong. When you publish it, you need to turn it around. Hi, Diana. Oh, I messed up. I have to remember not to type into that one. Okay. When you publish a temperature, something else needs to be ready to catch it. And so that's what this one does here. Alright, so it saves the temperature. The other way you can do it is like this. In the setup, you set a variable like so, like that, and you get that to point to a particular variable like that, and you tell it what it is, like so. So that's how that one works. Yeah, it used to be called a spark core, but now it's a particle photon. The core was before, they don't sell them anymore. The photon is the next version, and they changed the company name to particle. So you're right, except for each word. So that's how that's set up. We can verify it just because that's the fun way to find the problems that I set up. Okay. I need to spell temp update right. Let's see it again. Update on line 31. Update. Okay. So I thought that they would have this updated, but we'll just call it Spark. It's supposed to be particle, but we're doing Spark. There. So that's how that is. This is everything you need for a temperature sensor. We can see in the hamster tracker it running right now. Here it is. This one is using the pull method. So yeah, it's doing pretty well. That's a live reading. Now, second half, it looks like we'll be doing just the particle core stuff today, but that's all right. That's the temperature. Let's add the magnet sensor stuff, which involves a bunch of stuff. It needs to be done. It needs to have a little bit of debouncing. So we'll program that in. Let's use an LED sensor, just for the sake of being able to see if it was working. I'll show you how I use it here. There's an LED just right on there that turns on when the magnet is near it. That's how we'll use it. So we got the the LED sensor. We'll add the magnet switch A1. Now, I did a little bit of measuring to figure out how big the wheel was so that I could convert it to the proper number of feet. Okay, so this is the wheel diameter in feet. I told it pi just for the sake of being fast. This is, I set it so that after 5 seconds of not moving, of not going between low and high, it stops the trip, and that's when it will send data up to Keen IO. They have a limit on the number of messages you can send it, so in order to cut down on the number of messages, and also the particle core has a little bit of an issue reading things as well as sending HTTP requests, so it saves that till after it's done. So that saves a bit of CPU. Okay, so I set a debounce buffer of 25 milliseconds there. That's what that one is. Yep, I need to, it's an integer. And that's something I've been tweaking just to see what works best. Okay, so let's get some internal variables. We'll count the rotations here. Now, we need to set it, we need to know if it's near the magnet, and set it up kind of like a, what is it called, a memory state, a solid state, something like that, a state machine. So it needs to only activate some of these functions when it goes from low to high or high to low. So we set what its current setting is right here. And then we check it up like that. And we get the overall elapsed millis elapsed. The millis elapsed is the number of milliseconds that have been passed since the trip started. Okay, so how's that looking? You can verify it for the sake of verifying it. Okay, so all that's going so far. Alright, so there are a few things we want to track. We want to know the current speed. We want to know the average speed. Let's make that a float, because why not? Max speed. We want to keep track of the number of rotations in its trip and its distance run. So those are just functions we'll have to call as it goes. Okay. I might have some redundant code. But I'm always working on this. Okay, so there's that much. Now to set this up. Now, this is the temperature setup. Now we want to set up the LED, and we want to set up the magnet. LED sensor looks like this. Let's see, we named it LED2, which is silly. Let's just set it to LED. Here is. Alright. Bye, Techie Cat. Thanks for joining me. Now we get the magnet sensor. Same as the others. Magnet switch. Set that up to be input. Okay, so we've got all that going. And what do we do during the loop? Let's move that out of the way. Temperature, magnet. Alright, first off, we have to decide whether the magnet is now near the magnet and not, like if it's switching states. So, if is near magnet. Now there's a function we can call. Let's call this function void. Now when it's a function like this, it's going to return its own variable. It's going to return I'll go through this in a second, but let's get this logic going. If it's near the magnet, the function is currently the variable is what it was before. So if it's near the magnet and it wasn't near the magnet before, then we're going to turn on the LED, like so. Let's get these functions too. Void turn on LED. This is the hello world of IoT. Let's see, turn off LED. Okay, so to turn it on, we tell it to go high on the LED. Digital right, LED low. We tell it to go low, and then that's it. Okay, so we just turn two lines of code into one. Right here, turning on the LED. Now, it's found it near the magnet, so after we determine what it is, we set it up like that. Or else, it must be false. So, that means that we only had to check it once, check the function once. Now, this one is, if it's not near the magnet, but it previously was near the magnet, we're going to turn off the LED. We're also going to update the data. This is where we're going to increment all of it. We're going to increment the number of trip rotations. Oh, we also need to set it to false. Okay, so that's how that goes. Now, for the is the near the magnet, we need to read it in. Digital read the magnet switch. Okay, we now have the Boolean there. Now, the problem here is sometimes it has some really screwy off for a split second, then back on, and then so we need to make it hang for a little bit. Okay, so we're using the millis debounce variable that we set up right here. Okay, so we set that to 0. This automatically increments. It automatically goes up by milliseconds. So whenever you check it, it'll be however many milliseconds passed since the last time you set it. Now, right now, I'm only doing the debounce for the positive, for the negative, I suppose. This is if it goes low, which means that the magnet sensor turns off. Okay, so this one might be a little hard to understand, but here's what happens. It waits for it to be low for a while before it tells it that it's low. So the only way this will be false is when this grows higher than the debounce buffer that we set here. Right here. Hello, Camille Jew. I learned coding through a number of ways. I started playing with Visual Basic and Basic when I was really young, so that was pretty good. I made some games, made just like little basic things, and then I kept trying stuff out. I had internet classes in high school. I made the simple 90s style GeoCities web pages in the past too, and then in college there was a iOS and Objective-C contest, and I made a very basic Objective-C program with that. So in college I was a network administrator, so I did some scripting there. I worked for a company called i.TV and learned PHP and all that there. So I just had a lot of different languages, and so my current job I do Python and front-end coding too. I've also had a lot of experience doing just hackathons and just one-day projects and these sorts of things. So yeah, a hodgepodge of different ways. Alright, so back to this. What I had just done was I just set up this debounce buffer so that it'll return. Oh, does that need to be an integer? I think that it doesn't. Let's try that. Let's see if it verifies, because it's supposed to be a Boolean. Let's see what we're missing. We're missing semicolon at 97. .34. So we've already got a temp update, 45. Oh, we do. Oh, let's get rid of this one. Yeah. ActionScript is nice. It seems like that's the easiest way to create animations for Twitch streams. If you want to check out Latch and Friends coming up in about 25 minutes, he streams every day and he does ActionScript. .93. Let's see what 93 looks like. Okay. It is mad at that, so let's... Oh, it's because I named this wrong. There. Update data was not declared. 74. have I not set up update data? I have not set up update data. Void update data. That is the next one. Okay, here's what happens when we update the data. First off, we just found out that the rotations have incremented. Now, this one is checking if the trip time needs to be reset when it's on the first one, but we don't need to worry about that yet. This format is Arduino, so I'm coding in Arduino. I couldn't tell you the difference between the two because I've done so many languages that it just kind of all blends together. It's kind of like C. I think it might actually be C. Like so. Okay, so that's for trip stuff. Now, we can figure out the current speed like this by Alright, so that is feet per second because the velocity is the distance over the time. Now it's normally 2 pi r, but since we have half rotations, or since we have the wheel diameter, that's already 2r, right, like that. So that's the speed. And we are updating the variables that we've already set up here. Let's see, in the display variables. Current speed, average speed, max speed, trip rotations, trip distance. These things automatically update, so those are good. Average speed. This one was kind of weird, but we have the trip distance. Do we have the trip distance? Why don't we set the trip distance? Trip distance is the trip rotations divided by 2 times pi times wheel diameter. So the trip rotations is in half rotations, so we divide it by 2, and then we times that by pi, and then we times it by the wheel diameter, since we're going over the distance run around the circle, around the hamster wheel. Oh, let's do average speed now. Trip time minus the milliseconds between trips times 1,000, because we want it in seconds. So the average speed is in feet per seconds. Max speed. Oh, max speed is always just the max speed. So it needs to compare the current speed, and if the current speed is bigger than the current max speed, then we reset the max speed. So if the current speed is greater than the max speed is equal to current speed. When we update the data, we reset it. Because the milliseconds elapsed is the milliseconds between the magnet sensor going low to the magnet sensor going low again. Let's see what I gotta fix. I forgot to semicolon on 115. 114. 13. Like so. Could you explain the first if condition in is-environment? It looks like you're assigning sensor value equals high instead of evaluating. Maybe I am. That would be wrong. Yeah. Thank you for catching that. All right. That's definitely going to work a lot better now. Okay, so what we've done is check. We found the speed and the distance, and the average speed and the max speed of the wheel as it runs. Now what we need to do is figure out a trip. So we need to figure out when we need to reset it. So let's set that. All right, so what have we got? Now, we've set a trip rotations and a trip distance and a trip time right here. That means while we're in our loop, we need to figure out, so we've done the magnet one. All right. Now we need to know when we need to reset our trip. Okay, the millis elapsed is the amount of time between it going low and it going low again. Which means that if it's just not going low again, the millis elapsed will just go up high. The millis between trips we have set to be 5,000, which is 5 seconds. I've seen that this is usually enough to know when the hamster has stopped running. Alright. If we have data that we need to push, we need to reset the data. We'll reset the data. That's one of the things we need to do. Let's publish the data too. Okay, so an easy function, we need to set up these two. We need to set, let's just add these to the end. We need to reset the data and publish the data. Void publish data and void reset data. Okay. Just a second. Alright, so here's what publishing looks like. Particle IO uses, it used to be called Spark, and the Spark one, the Spark command here is like so. Alright, so here's how you can see how you can set up a webhook to see these variables. Like so. That publishes. Let's show you here on the web page again what it looks like when that happens. I have set the JavaScript of this page to update these variables with that particular published data. So here's the magnet sensor, here's a magnet, and we just run it like this, and if you watch the screen, it will show that the data is updating as it goes. At least I think that's how it goes. Ha. All right. So that's how you publish data. This would publish, since we set up publish data on only when there's data, and when it's this would only happen after the end of a trip. I've set mine up. Actually, I think that that might be somewhere else. When we update the data. There's got to be another place. Let me look. Publish data. Ah. This is how I did it. I set up... okay, let's reset the data and let's do this after this. Publish on a regular interval. Here. Okay? I've got 5 minutes to take care of this. Now, to reset the data, we reset these variables we have in our display. These here. Okay, here we go. We set the max speed to 0. We set the trip rotations to 0. We set the millis elapsed to 0. And we reset the data. Okay, so if we want to publish regularly, this is WebSockets. So if we wanted to publish every millisecond, it would be a ton of work. So what we want it to do is set on an interval that's enough to get the point across. So what we're doing here is we have to set a publish update variable right here. We can set this up in here too. Publish update. So that's set to 0. Now, if publish update is greater than 1000, so I'm just setting it to 1 second, it's hard coding, and the trip rotation, so we have something to send it, is greater than 0, then we publish the data like so, and we reset the one right here. When did I start streaming? I started streaming about 45 minutes ago. Alright, so that's how that goes. We hit the command, we reset the variable, so this will send a regular number. It'll publish this information every 1 second now. We could set it lower, we could set it higher, but in order to prevent the particle core from being overwhelmed, sending data up all the time, it needs to keep receiving data, so we keep it so just once in a while. This is my first game or web development stream. I've done some game stuff before. I guess I have streamed doing my Ludum Dares, but yeah, this is the first of a regular series. I'm going to stream for an hour every day from 8 to 9 a.m. Pacific and see how that goes. Let's verify this, make sure it's all going. Have one last thing, because it's trip rotations, not rotation. And we're good. Okay, so this is how it looks. Yeah, so first, regular stream. Let's see, maybe I can prod the hamster to get up. Hamster, wake up. Hey, alright. You can see in the corner here, here's Jessica Rabbit Hamster Swan. She's a cutie. Yep, and she normally sleeps during the day. You can see on the chart that it is right in the middle of her sleeping time. She normally runs right around here. Let's see, it's 11 p.m. to 7 a.m. This one is 6 a.m. Yeah, so she runs till 5 or 6 a.m. every day. And this is how much she runs. This is 13,000. I've set these ticks to be 1 mile. So this is a little over 2 miles. This is almost 2. This is 1. This was a big one, and she got 1, 2, 3, 4, 5 miles. So thanks for following me. That's very kind. I hope to be entertaining through the entire week, and I hope to keep having stuff to show off after the week. Okay, so yeah, if you want to check out this here, I will send a nice link so that it's easy to get to it if you can't read where it is right there. But that's the basic setup. That is how to follow its temperature, how to follow its distance run, and it finally publishes the data here. What I did not show was using the HTTP client to send the data to Keen.io, and they're the ones that make these charts here. So these two are the ones that I made today. But the fun part is, here I can show you what it looks like on my test sheet. This is what I do for Keen.io. This is it. In fact, why don't I just do it? I'll run through it like this. Alright, this is how you send data.keen.io. Void send trip data. Okay. What we need for this is we need a HTTP client, which I've added the thing here. I'm pretty sure I don't have one already. HTTP, oh, it looks like this. Client, HTTP. Okay, I'm hitting all sorts of buttons. Okay. Now, when we reset the data, we want, actually before we reset the data, when we have found that it is send trip data, like so. So that's how that goes. Alright, so here's how this works. Thanks, Grandlier, if I haven't already said that. I am really happy about this project. It turned out really well. Now, we need a request. Okay, we have the client, and we make a request like this. HTTP request T request and HTTP response T response. This is in the example in the HTTP request, so you don't have to worry if it looks weird. You can check their example code. Oh, sure. Let's see. Right now I am a web developer for NBC Universal. I am using Python right there. I really like Node.js. I like the potential that it has, and it's just been growing a lot. JavaScript is pretty good for any web developer, and Node.js just kind of builds upon that. I think that JavaScript and C are really similar, so the stuff that I'm doing here just kind of makes sense to me. Okay, so this is just regular HTTP request stuff. Okay, so this is Keen.io stuff. So I'm going to do placeholder stuff. Project ID events trip. Now I just named this whatever I wanted. Data name. Just name it whatever you want, and that works. And let's see, I need to set the API key equals API the keen API key, like that. Now this is going to be a post, and I just created the JavaScript just because. Yeah, that's good. Web development's good. It's lots of fun for me to make things like this project, but I have also made games using WebSockets, and so everyone goes to a web page and their phone or their device is used as a controller where everyone works together. Yeah, I haven't got the hang of this talking and typing at the same time. And if you can see what's going on, I'm just creating a JavaScript string with all of my variables, like so. Plus string distance. So at the end of every trip, oh, it's not just called distance, it's called trip distance. Oh, this is important too. Plus time. Now, you should probably put this stuff on multiple lines. I think when I did this, I put it into a separate editor, figured out what it's supposed to look like, and then you can see the end of it there. It showed what it was supposed to figure out what it was supposed to look like, and then pasted it in here all in one line. So it's not the prettiest, but it gets the job done. Okay, so now we've set up an HTTP request. Now we use the client to post the request, and we put the response in the response, and we don't need to do anything with the response, but that sends the trip data. So that's it. That's how that goes. We're good. I'm going to end now because I need to catch a bus. But that's how it works. Let's verify just to make sure everything goes happy, which it didn't. Expected that before request. 169. Okay, so that's got something messed up in it. So why don't I... Oh, the problem is this right here. No semicolon. I'm glad I didn't have to mess with that. Headers was not declared in this scope. I did not put headers on here. Okay, here's what headers is going to look like. I believe this is in the example one too. So that's how that's set up. Thanks for joining me. Tomorrow I'm going to do a Wi-Fi locator, which means you'll use this thing to look at nearby Wi-Fi routers and use their MAC addresses to figure out your location. This will work really well for things like putting it in your car. In case it gets stolen, you'll get a general idea of where it goes. you need to be able to send the data to, and you do that by connecting to an Xfinity Wi-Fi hotspot, which are all over the place. Or you can also set this up to look for open networks and join them to be able to send data out. And that's how that goes. Thanks for joining, and I'll say goodbye now.